Hi everyone, welcome to Ken Vibes with AJ, and today we are going to learn about functional groups, what they are. Functional group is a specific group of atoms or bonds within a molecule that determines the molecule's chemical property and reactivity. So these functional groups are responsible for the characteristic behavior of organic compounds. So let's consider the hydroxyl group, which is found in alcohols. And examples of an alcohol, we have the ethanol, methanol, etc. So this functional group imparts the properties such as hydrogen bonding capacity and increased solubility in water. So this property that I just mentioned gives the characteristic feature of the alcohol. Now, functional groups are typically classified based on their chemical behavior and the types of atoms they contain. So they are categorized based on their chemical properties such as the acidity, the basicity, reactivity, and the specific atoms they contain such as oxygen, nitrogen, and sulfur. So let's take the carbonyl group for example. It's a functional group found in various compounds such as the aldehydes, the ketone, and carboxylic acids. So this group is characterized by its ability to undergo neutrophilic addition reaction and its presence in compounds with carbonyl functional groups. So the property that I just mentioned, ability to undergo neutrophilic addition reaction, is due to the functional group which is present in these compounds that I mentioned, like the aldehydes, ketones, and the carboxylic. So a type of functional group, we are going to talk about the alkyl groups. So an alkyl group is derived from an alkane. So let's take an example of an alkane being a methane. So methane has carbon binded to 4 hydrogen atoms. So when one of the hydrogen is lost or one of the hydrogen is removed, we then get CH3. Now the CH3 is no longer pronounced as a methane but rather a methyl due to one loss of what? The hydrogen. So it is one aspect of a functional group. Now let's go to the second batch of functional group. We have the alkyl halides. Now alkyl halides are also known as haloalkanes. They are organic compounds containing one or more halogen atoms. So when we say a halogen atom, example is fluorine, chlorine, bromine, or iodine bonded to an alkyl group. We already know an alkyl group, an alkene which loses a hydrogen. You get an alkyl group. So where the chlorine is can be bromine, can be iodine, can be fluorine. Now let's look at alcohols. Alcohols have the hydroxyl functional group. So it consists of 2 carbon atoms bonded to each other with one of them attached to an OH group. So an alcohol, they have the hydroxyl group. Let's look at esters. Esters, okay, this one is ether. Esters is down there, so we'll talk about that one later. Ethers are organic compounds characterized by. So now let's look at ethers. Ethers are organic compounds characterized by an oxygen atom bonded to 2 alkyl or aryl groups. So they have the general formula R bonded to oxygen and an R, where the R can be an alkyl group as we mentioned above, or an aryl group. So it consists of 2 ethyl groups bonded to an oxygen. Okay, ethyl groups bonded to an oxygen. So 2 alkyl group can also be known as ethyl, because ethane loses 2 hydrogen to become an ethyl. So amino, now this one is amino. Amides. Amides are organic compound containing a nitrogen atom bonded to one or more alkyl or aryl groups. So an example is the methyl amide, which is CH3 and H2. So a primary amide where one hydrogen atom of ammonia is replaced by a methyl group. Let's look at aldehydes and ketones. So aldehydes and ketones are organic compounds characterized by the carbonyl functional group C double bonded to oxygen. So in aldehydes, the carbonyl group is bonded to at least 1 hydrogen atoms, whereas in ketones it is bonded to 2 alkyl groups or aryl groups. So you can see the structure below. Now let's come to carboxylic acids. Carboxylic acids are organic compounds containing a carboxyl functional group, that is the COOH. They are characterized by high acidity due to the presence of a hydrogen atom that can dissociate as a proton. So let's come to the structure. Tells you that it has that functional group COOH. Is a carboxyl functional group. Let's look at esters. Esters are organic compounds derived from carboxylic acid by replacing the OH group with an alkoxy group. So O binded to a carbon. That is not O, sorry. Oxygen binded to a carbon is called an alkoxy group. So we can have methoxy. So it means a methane binded to an oxygen. It's called methoxy. So where R is a carbon binded to a carbon is called an alkoxy. Let's look at amides. So all these that I've mentioned, they are organic compounds. So amides are organic compounds derived from a carboxylic acid by replacing the hydroxyl group, which is the OH, with an amino group. So the OH in carboxylic acid, which is the COOH, that OH is replaced with an amino group to get our amides. So you can see the structure below. Thank you guys for paying attention, and we will end here.